graph the following equations on the same graph. So, the first thing we need to do for each of these equations is to complete a table. So, the x is the independent variable, and the y is the dependent variable. Or, you can think of the x as the input, and the y as the output. So, that means we're going to choose values for x, substitute them in, do some arithmetic, and find out what y is. For instance, if x is 0, then the y will equal 0 plus 1 squared times negative 2 plus 8. So 0 plus 1 is 1, 1 squared is 1, 1 times negative 2 is negative 2, and negative 2 plus 8 is 6. So 0, 6 is here. And you'll notice that I'm going to plot the points as we come up with them in the table, as opposed to making the entire table and then graphing all the points. The reason I'm doing this is because I think if we plot the points as we go, we'll have some sort of idea of what the shape of the graph is. Whereas if you don't plot the points as you go, you might not really notice what the shape is at the beginning, and you also might not catch errors that you might make. Now, let's try both some positive and negative values for x. I'll start with a positive one, since the arithmetic will be a little easier. So when x is 1, we have 1 plus 1, which is 2. 2 squared is 4. 4 times negative 2 is negative 8. And negative 8 plus 8 is 0. So 1 comma 0 is here. Next, 2. 2 plus 1 is 3. 3 squared is 9. 9 times negative 2 is negative 18. And negative 18 plus 8 is negative 10. I can also see as I'm going here that this is going to be very close to coming off the grid. So I have a feeling if I plug in the 3 for x, it'll be off the grid. So I'll try some negative x's and see what happens. So if x is negative 1, negative 1 plus 1 is 0. 0 squared is 0. 0 times negative 2 is 0. And 0 plus 8 is 8. So we have the point negative 1, 8. Next, if I put in negative 2. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 times negative 2 is negative 2. And negative 2 plus 1 is negative 2 plus 8 is 6. So negative 2, 6. We can clearly see that this is not a linear graph. Let's try negative 3 next. Negative 3 plus 1 is negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8. And negative 8 plus 8 is 0. So negative 3 comma 0. So we can see that we have this graph which seems to be sort of U-shaped and opening down. Now we have this point here. I would suspect that there's another point that corresponds over here. But let's just put in negative 4 for x and make sure that that really is the case. So if x is negative 4, then negative 4 plus 1 is negative 3. Negative 3 squared is 9. 9 times negative 2 is negative 18. And negative 18 plus 8 is negative 10. So we can see that there are these y values that match. And negative 4, negative 10 is here just as I suspected it would be. So our graph is this upside down U shape. Now, let's do the same thing for this absolute value equation. So again, I'll start with 0. 0 plus 3 is 3. The absolute value of 3 is 3. And 3 minus 7 is negative 4. So 0, negative 4 is here. I'll put in 1 and 2 next. 1 plus 3 is 4. The absolute value of 4 is 4. And 4 minus 7 is negative 3. 1 comma negative 3 is here. Next, if I put in 2, 2 plus 3 is 5. The absolute value of 5 is 5. 5 minus 7 is negative 2. 2 negative 2 is here. It appears that this graph just keeps going over 1 and up 1. Let's put in some negative values to see if that stays true. So, if I plug in negative 1 for x, negative 1 plus 3 is 2. The absolute value of 2 is 2, and 2 minus 7 is negative 5, which is here. If I plug in negative 2, negative 2 plus 3 is 1. The absolute value of 1 is 1, and 1 minus 7 is negative 6. Here. If I plug in negative 3, negative 3 plus 3 is 0. The absolute value of 0 is 0, and 0 minus 7 is negative 7. Now, something interesting happens when I plug in negative 4. Negative 4 plus 3 is negative 1. The absolute value of negative 1 is positive 1, and 1 minus 7 is negative 6. So now the graph starts going back up from right to left. If I plug in negative 5 plus 3 is negative 2. The absolute value of negative 2 is 2, and 2 minus 7 is minus 5. So negative 5 is here. It appears that we're getting this V shape. Let's see if this point is what we think it is. I think it's negative 6, negative 4. Let's see if I plug in negative 6 for x, if I indeed get negative 4. Negative 6 plus 3 is negative 3. The absolute value of negative 3 is positive 3, and positive 3 is indeed negative 4. So we get this V-shaped graph. Now, there are a few things that I want you to notice. First of all, in the U-shaped graph, we have this point here, which is especially important because it's, you could call it the turning point of the graph. It's the highest point on the graph. It's where the graph changes from increasing to decreasing. Now there's a similar sort of point on the blue graph, but it's actually this minimum point of the graph. It's the lowest point where the graph changes from decreasing to increasing. Now these 2 points have a name. We call them the vertex of a graph. So on the blue graph, the vertex is this point. And if we take a look at the table carefully, we might be able to pick the vertex out. This vertex is negative 3, negative 7. You'll notice that on either side of the vertex in the table, the y values repeat themselves. The same is true of the graph in red. You'll notice that these y values are repeating themselves, and this point here, negative 1, 8, that is the vertex. We say that these graphs have symmetry, which means that if we were to fold our paper along the vertical line that goes through the vertex, the one part of the graph would end up on top of the other part of the graph. Now, as I said, the coordinates of the vertex are negative 1, 8 for this red graph, and the coordinates of the vertex of the blue graph, well, that vertex is negative 3, negative 7. Now, you might notice that there's a relationship between the coordinates of the vertex and the equation. Notice that this vertex is negative 3, negative 7, and here in the equation we have plus 3 and minus 7. And in the red graph, the vertex is negative 1, 8. And in the equation we have plus 1 and plus 8. So if you look in the equation, it appears that this number inside of the squaring, or inside of the absolute value, it appears that that number is the opposite of the x-coordinate of the vertex. And we'll also notice that the number outside here, the positive 8 and the minus 7, those correspond to the y-coordinate of the vertex. And in the case of the y-coordinate, it's the same as this number in the equation, as opposed to the opposite. One final remark or observation is that this number here in the red graph is negative. And notice that the U shape opens down. If you look at this equation here, this coefficient, which we don't bother to write, is 1. And 1 is positive, and the V shape opens up. In the future, you'll play around with equations that look like these two equations, and you'll see how the various numbers affect what the graph looks like, either whether it opens down or opens up. We'll also see how we can move the vertex around, and we can even see how we can change the equation to make the graphs either skinnier or more narrow.